Welcome to this lecture series here, where we cover the topic of differentiation in Mathematical Methods Unit 2. Here's the table of contents here. If you'd like to pause the video and check out what the topics are that's covered in this series. And the purpose of this series here is to go through each topic, but for you to watch and also relearn if you need to. The first concept that we're going to go through here in this video is about rates of change, and particularly this terminology called average rate of change. Now, we are introducing these quote-unquote new concepts or these new terminology, so it's important that we know and understand what it ties back to from our previous knowledge. So the average rate of change is essentially the exact same as finding the gradient between 2 points, which we all know is y2 minus y1 over x2 minus x1. However, we do want to kind of evolve this definition from essentially what we learnt in year 8 or year 9. So if we have a general function f of x, I'm just going to rewrite this here as y equals f of x. Because we're going to start relating this back to the coordinate system. The average rate of change of the function over the interval a, b, so these are our x values, or our domain, is the gradient of the straight line joining these 2 points, a, f of a, b, f of b. Okay, so first of all, we can see that the average rate of change here is a very similar formula. In fact, they are exactly the same. We are just presenting them in a different format here. Now, how did we get this? If we consider our x value and our y value, then we can also take into consideration that our y is the same as f of x. So instead of writing xy, we can write x, comma, f of x. Essentially what this f of x means is that whatever our x value is here, we're going to substitute into our f of x with that same x value. So this comes to show that if our coordinates are a and b for our x values, like so, you can see that our x value is a, therefore our y value will be f of whatever our x value is. In this case here it's a. So therefore, the other coordinate that we have, which is when x equals b, is b, and our y value is when we substitute in the x equals b into our f of x, which becomes f of b. Okay, so since we have these two coordinates here, we can essentially label them as an x value and a y value, an x value and a y value. How do we tell the difference between the two? x1, y1, and x2, y2. So let's go and compare these. If we fall back onto our y2 minus y1 over x2 minus x1, we'll have f of b, which is our y2, minus our f of a, which is y1, over x2 minus x1. Okay, so essentially these two formulas are the same. The word average rate of change is exactly the same as our gradient. So that's all I want you to take away from this here. You can see our graph. We can see 1 coordinates, 2 coordinates. And if we find the gradient between these 2 points here, it will create a line, and you are finding the gradient of this line here. Here are our coordinates as we defined at the top here. So this is just an example or an illustration. So don't forget to pause, rewatch the explanation if you need to revise or take this to process it again.